Hi, everyone. We'll get started in a minute. Ken was here. I'm not sure what happened. Maybe he needed to reconnect. So let's just give it a second. Thanks for joining the session. This session is, I should have known before I clicked on my mic, sorry, 3D printed key guards. And Ken was here, so hopefully he'll be back in just 2 seconds. Hang tough for a minute.
Hello. Anyone there?
Hey, Ken, I'm here. I saw you were here and then you were gone.
I lost internet.
I kind of thought and I warned everybody that you were here and then you were gone. So to give it a minute or two.
Yeah, please. My cable modem just died and then is coming back. So it will take me a moment to get set up again.
Yeah, that's perfect. We're an understanding group of technology glitches, so no problem. That's kind of what I figured because your slides were up and everything. I saw the whole thing was ready to go.
Yeah, I don't even want to talk about things failing at the last second. Okay.
And isn't that the way it usually goes? It's all right. It'll all come back.
So here, I think we're set up for there. Let's get this swapped properly. And now sharing with sound.
There you go. You're up.
All right.
Thanks, Ken.
Hey, thank you. So, yeah, I'm sorry for everyone who had to sit through at least the first couple of minutes of this. I welcome and thank you for choosing to attend my presentation. My name is Ken Hackbarth. I'm president of Volksswitch.org. Volksswitch is an organization devoted to the democratization of assistive technology by leveraging the power and promise of 3D printing. Volksswitch is also committed to designing customizable 3D printable devices and putting those devices in the hands of the people who need them. So the topic for this presentation is 3D printed key guards, your gateway to 3D printed assistive technology. So on this slide, I've attempted to capture the essence of this presentation as an image, and at the same time call out the two arguments that I need to convince you of. The first one is I need to convince you there's a wealth of high value, freely accessible, 3D printable designs that you can take advantage of right now. That's this region in the center. And even if you already believe that, you may believe that there's an impenetrable wall of technology and finance between you and those devices. Well, my second goal is to convince you that 3D printed key guards are the way, are the gateway through that technological wall to the wealth of available AT inside. But first we need a little context. So 3D printed is part of both of these proposals. And so let's make sure everyone's on the same page as to what 3D printing is. This is the simplest definition that I can think of for what 3D printing is. 3D printing takes a digital model and layer by layer turns it into a physical object. So a digital model is a virtual object created using a specialized software called computer-aided design or CAD software. In this example, someone has created a virtual rabbit wearing sunglasses. That digital model is then sliced into a series of horizontal layers by another piece of software called, of all things, a slicer program. The slicer then tells the 3D printer to print each layer on top of a previous, starting at the bottom. Yep, doing that again. Okay. So 3D printing takes thermoplastic filament or photosensitive resin to create the final physical object, and the instructions can be repeated over and over again to create additional copies. Here we have 2 of the rabbits created just using 2 different filament colors. But how does 3D printing work in actual practice? How does the design and printing process work? Well, this slide shows the process for creating an assistive technology device. The process exists both in the virtual world of computer software and in the physical world of 3D printers and human beings. The process begins in this upper left-hand corner with the creation of a design of 3D model. In truth, the process actually begins with the identification of a need or a problem and a discussion of possible solutions. You then draw up the leading contender, the leading solution, as a 3D design using CAD software. Step 2 is to slice the design using slicer software. You then print that design on your device, on your 3D printer. And then the 4th step is a critical one of testing the device. Unfortunately, all great ideas on paper don't necessarily translate into great ideas in the real world. So if you're like the rest of us, the trial will identify shortcomings of your design, and you'll need to go back to the first step in the process of modifying that design, slicing it, printing it, and retesting it. So the process iterates until you confirm that your device meets the needs of your customer. And alternatively, it's possible you may find out that this need cannot be met with a 3D printed device. Why is 3D printing unique? How does it differ from traditional manufacturing? Well, 3D printers and the materials they use are relatively cheap. They are general purpose by their nature, both the materials and the 3D printers, and can create something on the second run that is entirely different from the item you created on the first run. Traditional manufacturing methods, on the other hand, utilize expensive special purpose machines and processes. Once those machines and processes are in place, there's no tolerance for changing the final product. On the other hand, because all of the software support for design, because of all the software support there is for design and the simplicity of the implementation, you can implement 3D printed solutions very quickly. In the traditional manufacturing world, a tremendous amount of time is put into the design of the product and the process for producing it before a single machine is ever turned on. Rapid production of a physical object through 3D printing and the fact that the cost of materials was very small encourages iterating until the final design is just right. On the other hand, traditionally, expensive machines, materials, and processes force a traditional manufacturer into a result that is pretty much locked in stone. Inexpensive 3D printers and the plastic filament make it possible to have a 3D printed factory, 3D printing factory, local to you in your home or your business, and put the process close to the people who will use the end product. That facilitates their involvement in shaping the design so that it actually works for them. On the other hand, traditional manufacturers must design for an average customer and can't accommodate customization and personalization of their products. So with that context, let's take a look at some actual examples of freely available assistive technology designs. So I'm going to quickly cycle through several examples. Each example will include a picture of the device and the cost of the plastic required to print one. The title of each slide includes a hyperlink to that 3D model. So if you download a copy of these slides from the link I provided on the Google page, you have easy access to these models should you find something that seems really attractive. But let's go ahead and quickly move through these examples.
Doing it or they are, but your script shows on the bottom of my screen.
That's just this.
Yeah.
No, that's me.
Oh,
No, that's.
But I see it too.
All right, so that was rather fast. But so let me see, you should be able to hear me. Yeah, okay. But I'm not seeing the captioning on the bottom. So here's a compilation of some of the best sites to visit if you're looking for AT designs. The first two sites, Thingiverse and My Mini Factory, are repositories of 3D models in general. So you'll need to search specifically for assistive devices, but they have hundreds of designs. The remaining sites in this page are focused specifically on assistive technology. So if you get into modeling AT yourself, I really encourage you to post your designs to at least the Thingiverse and Makers Making Change sites to share with other people. So downloading and printing free AT designs is one thing, but I think the possibilities available to you when you have your own personal design and manufacturing capability can be a game changer for you. So let me start by telling you a story.
Last year, I attended a cooking class at a facility in Colorado that serves adults with physical and developmental disabilities. A young woman in the class was asked to come to the front, was given a bag of sugar, a scoop, a large mixing bowl, and a glass measuring cup. And she was asked to scoop out 2 cups of sugar and put it in the large bowl. She never successfully completed the task. I thought later about how difficult the task is. It's difficult to manipulate the scoop inside the bag, unless the scoop is so much smaller than the opening in the bag. As you look down on the glass measuring cup, all the writing is backwards, and there are a number of lines that have nothing to do with what you're trying to measure. If you happen to overfill the measuring cup, how do you get the right amount of sugar or flour back in the bag? It occurred to me that there's another baking ingredient that's actually very easy to measure: baking powder. That's because the baking powder container comes with a special shelf that makes measurement as simple as choose the correct size of measuring spoon, scoop up a heaping amount of the powder, and then scrape the top of the spoon against the shelf. Excess powder falls nicely back into the can, and you're left with the exact measurement you need for your recipe. Is there a way to replicate the process with sugar or flour that normally come in 5-pound bags? Here's what I came up with. We can easily get measuring cups that hold a specific amount of something when filled to the top. I just needed a way to store the sugar in a container that I can add a lip to. I discovered a plastic storage container for shoes online. It'll easily hold 5 pounds of sugar. It also has a lip at the front top edge of the box that can be used to scrape off excess sugar. The problem with the box is that the drawer can be pulled out too far, and then you run the risk of sugar falling behind the drawer when it's scraped. So I needed a way to stop the drawer when it was in just the right position for the scraping step. I took the box apart and saw that it had channels in the bottom where I could mount a pair of stops. I broke out a ruler in my CAD software and soon came up with a design for a pair of stops that would fit nicely and securely in those channels. I reassembled the box, and now it works perfectly. Measuring out the correct amount of sugar or flour is now as simple as choosing the proper measuring cup, scooping, and counting the right number of scoops. The point of the story is that when you have your own design and manufacturing capability, you're free to focus on changing the task itself rather than training on an already confusing task.
So how much does that solution cost? Well, the shoebox was $10, and it cost me 50 cents to print those stops. So I hope I've at least piqued your interest in what's possible with a 3D printer. So what's the quickest and easiest way to get there? I believe the answer is 3D printed keyguards. So I'm sure many of you are already familiar with keyguards. For those who aren't, a keyguard is a plastic plate that sits on top of a keyboard, or now much more often a tablet. The plastic limits access to the tablet to only those places where openings have been cut in the plate. Keyguards help people with fine motor control more effectively interact with the app on their tablet. They also allow people who are easily fatigued to rest their hand on the tablet without triggering some action within the app. And finally, they can make, as a result, a huge difference in users' productivity. Well, how many keyguards do you need? That'll depend on the number of tablets and apps that you'll use or recommend, how many ways the apps can be configured, and how many tablet cases you may use now and in the future. If you only recommend 2 different tablets, each with 2 different cases running 2 different apps, and 4 different configurations for those apps, you'll need 2 times 2 times 2 times 4, which equals 32 evaluation keyguards. If, let's assume, a quarter of those break or are lost over time, you'll need an additional 8 keyguards. That totals 40 evaluation keyguards. A user will need new keyguards as their skills improve or degrade over time. And there are bound to be new tablets, cases, and apps in the future. Now I can hear what you're thinking. You're thinking, hey, there's no way in the world I could possibly afford 40 keyguards, so this whole argument is just crazy. But would it be crazy if you could reduce the cost of the keyguards by 99%? Would that change your view of how many evaluation keyguards you should have? Well, here's a real world example. I designed and printed evaluation keyguards for an SLP at Imagine, Colorado. They have 2 different tablets, one of which can be in 2 different cases. They only support one AAC app called Go Talk Now, and there could be 4 possible layouts for that app when they're doing evaluations. But that meant she needed a total of 10 keyguards just to perform evaluations. How much does a commercial keyguard cost? Well, here's a page from the Keyguard AT website. Keyguard AT is the largest producer of laser cut keyguards in the US. They may even be the largest globally. I purchased a keyguard from them for touch chat running on an iPad 2, and the final cost was $71. Logan Tech, another supplier of AAC software and systems, they also sell keyguards for their systems, and they can cost as much as $150. But what if I designed the keyguard myself and had it 3D printed? First, the question is, how hard is it to design a keyguard? Let's take a look at how easy it is to design a 3D printable keyguard. I've downloaded the free OpenSCAD and free keyguard.scad programs from the web. Complete instructions can be found on the Volksswitch website. When I launch the 2, I see a screen like this. On the left is a depiction of the keyguard as currently specified. On the right are a set of expandable sections with options for customizing the design. I'm going to design a keyguard similar to the one that I purchased from Keyguard AT. First, I'm going to specify the tablet. In this instance, an iPad 2. I can choose to expose or hide the camera and home button, but I'm going to leave them exposed. I can also swap the location of the 2, and that might be necessary depending on the tablet's case. A detailed explanation of all the options and their implications for the design can be found at the Volksswitch website. Next, I'll specify the layout of the TouchChat app. I'll specify the heights of various components of the app. I can take the measurements using a metric ruler or by counting pixels in a screenshot. According to my measurements, the status bar and the upper message bar are a combined 11 millimeters in height. Note that the picture on the left updates with each change, so I can immediately see if I've made a mistake. The upper command bar is 9 millimeters in height. I'll expose the message bar, but not the command bar. There is no lower message bar or command bar in the TouchChat app, so I'll leave these unchanged. I can provide easier manual and visual access to the message bar by changing the bar slope from 90 degrees to 45. This is only possible because we will be 3D printing the keyguard. This is not possible for a laser cut acrylic keyguard where every cut is at 90 degrees. Now we'll lay out the grid area. The app will have 5 columns and 5 rows. I could widen the rails between the buttons and change the slope of the rails. Again, laser cut key guards can only have 90-degree cuts. I can change the shape of the openings from rectangular to circular, or from circular to rounded rectangles. And I control how rounded those corners will be. But let's go back to a simple rectangular openings, since that's what I ordered. I have the option to cover certain cells in the grid or merge them both horizontally and vertically. I can make fine adjustments to the location of the rails by adding padding, but that's not necessary with the TouchChat app. We're almost done. The last thing we need to do is settle on the mounting method for the keyguard. If I'm not using a case, I have the option to use suction cups, in which case cuts are made to accommodate the top of each suction cup. I can go with Velcro, in which case recesses are added to the underside of the keyguard. I can go with screw-on straps that I purchased from Keyguard AT, in which case cuts are made to accommodate those straps. I can go with clip-on straps and 3D print the clips. Finally, I can use micro suction tape, in which case I don't need any special mounting features. But it's rare that a tablet doesn't go into a case. The keyguard I purchased from Keyguard AT was going into an AVAWO Kids case. So let's go to the tablet case section and tell the program that we have a case. We now have to tell the program the size of the opening in the case, since that's what determines the overall size of the keyguard. The opening of my case is 163 millimeters high and 215 millimeters wide. It also has rounded corners with a 5 millimeter radius. Now we'll look at the options for mounting this keyguard in a case. I can still go with clip-on straps and print my own clips. I can choose the traditional slide-in tabs. And finally, I can go with raised tabs. This may be my best choice for a hard-sided case with a screen protector. But my case is soft-sided, so I'm just going to wedge the keyguard into place, so I'll choose No Mount. My design is ready to go, so I'll tell OpenSCAD to render my design. Lastly, I'll tell it to export my design as an STL file. The next step is to print it. All right, so we have the design for the keyguard. Now let's look at how difficult it is to actually implement that as a real-world object. This video is going to show you how you take an STL file and turn it into a printed keyguard. So we produced an STL file from OpenSCAD. And now we're just going to take it and drag it and drop it into our slicer. In this case, I'm using the Prusa edition of Slicer. You may be using an entirely different slicer program for your printer. The first step in this program is to slice the model, and then you're just going to export the G code. This is the language that the printer understands. And I'm going to put it on an SD card. That didn't take very long, so it's now on the SD card, and we can load the SD card into the printer.
The SD card is loaded. The printer is about to begin printing the keyguard. It'll take about 4 hours to print the entire keyguard. Printer is going through a leveling process, and then it will begin printing. We won't see the entire print because 4 hours is a long time, but we will come back eventually at the end to take a look at the finished keyguard. Alright, it's time to remove the keyguard from the build surface. So we'll take it, crack it, take it off. So there we have it, finished keyguard. Alright, time to see how our new keyguard actually fits. What we're going to do is we're just going to wedge it right into the case. There it is. Nice fit all the way around, and it's just not going to come out, but you can pull it out quite easily and swap in a new keyguard. All of that for about $1.
So, yeah, I hinted at it already, but how much did that keyguard print? How much did it cost to print that keyguard? Well, the slicer tells me that. If I tell the slicer in advance how much the filament costs, then it will calculate how much filament is used and how much the final print will cost. In this case, 97 cents. So let's take a quick look at some examples of what kind of keyguards you can print with this designer from Volksswitch.
Here are a collection of keyguards, all of which were designed with the Volksswitch keyguard designer. They're roughly organized into grid-based keyguards, hybrid keyguards, and freeform keyguards. The hybrid keyguards are a hybrid of grid-based with some freeform elements. We'll take a closer look at these keyguards next. Here are our first set of grid-based keyguards. They're all designed to fit directly on the surface of a tablet without a case. You'll notice that they could be in portrait or landscape mode. This keyguard is held in place by microsuction tape, which holds very well to the glass of the tablet without leaving any residue behind. It can be applied and removed multiple times. This keyguard is using clip-on straps. Remember, you can print your own clips. This keyguard uses Velcro, and this one uses suction cups. More keyguards, some that use multiple colors of filament for interest, for personalization. You can see both the slide-in tabs as well as raised tabs. Here is the here's just another example that shows you how many holes can be in the grid without any problem in printing. These are both clip-on straps, and under certain circumstances, like with soft-sided cases, you don't even need the straps in the back for them to hold tight. You can even use these clip-ons with keyguards that have screen protectors and leave very little space between the edge of the screen protector and the edge of the active area of the screen. A freeform keyguard simply takes a piece of plastic and punches holes in it of a variety of shapes wherever they are needed. So this is just a keyguard supporting a standard email app on an iPad, and this keyguard supports the Acorn AAC app, which uses a very different algorithm for producing phrases, and it has a very specific layout for that purpose. Again, in this case, the program is told where every hole should be, what its size should be, what its shape should be, and you're able to produce an arbitrary keyguard using that logic. These are all hybrid keyguards, meaning that they're based fundamentally on a grid of openings, but they also allow for openings to be made outside of the grid in very specific locations. So this is a keyguard made for Go Talk Now, so is this one. These two show cutouts made in the message bar for a couple of menu items in the Touch Chat app. This one shows that you can add raised features as well, buttons like that, or walls around a cell, or little walls that lead to another location. And it also demonstrates the merging of cells and the covering up of certain cells. Another nice feature is you can add text engraving to a keyguard on top, and I don't know how well this shows up, but here's a serial number on the underside of the keyguard. And lastly, you can do some clever things with color again, using multiple colors of filament. And this also demonstrates a feature of printing keyguards on smaller than the largest build surface. So I can add a dovetail joint at some point in the keyguard and use that joint to bring two pieces together that were printed separately. Depending on the tightness of the joint, you may not even need to use some kind of adhesive. This is also a hybrid keyguard, but I bring it to your attention just to show you that you can print very large keyguards on smaller size printers, but they have to be printed in two parts and then joined together. You may recognize this as an Accent 1400 keyguard with special case additions added so that you fill in all of the open space in the case. Then you take these two, you overlap the dovetails, a little light tapping, and you've got a keyguard that really actually isn't going to come apart. But you would have otherwise had difficulty printing this on a printer even as large as 300 millimeters.
So we'll go ahead and stop that one right there. We're getting short on time. Let me quickly move through some of these remaining slides. Can you afford a 3D printer? Well, here are a couple of printers that, just to give you some idea of pricing, I have both of these printers. One is the Artillery Sidewinder X1. It's about $450. This one from Prusa is $750 in kit form and $1,000 assembled. I really do recommend kits if you decide to go and purchase a printer, because you will learn so much in the process of building the printer that later maintenance or any trouble you run into will not seem daunting at all. I love both these printers. The one thing I would say, if you're going to be printing Keyguards, you would want something with a build surface that has a major dimension of at least 250 millimeters. How do you justify the cost of a printer like that? Well, if you need to invest in Keyguards, the differential between a commercial keyguard and a 3D printed keyguard is so great that you could justify that 3D printer after printing just 5 to 10 keyguards. And remember that example I gave you for Imagine Colorado, they needed 10 even for their simplistic set of supported apps and tablets. Once you have the 3D printer, well, now you can explore a full range of 3D printed designs. And now you can also think out of the box when you're trying to find solutions to your users' needs. So based on that information, could you put together a business case or a grant proposal or a bake sale to come up with $450 to $1,000? And are there any ways to obtain 3D printed AT without a 3D printer? So if for some reason you're still reticent to go all the way to getting a 3D printer, if you're in a school district, there are lots of STEM programs in those school districts. And even middle school, high school, they often have access to a 3D printer. They often don't have a good sense of what those 3D printers can actually do. And you may finally give that teacher and the students in the class a reason to learn about 3D modeling and use their 3D printers. There are online printing services that could save you 2/3 the cost of a commercial keyguard. These are online services associated with Thingiverse. You may have a local library. This is one very near to me that charges only $1 for every 10 grams of filament. The keyguard uses about 40 grams of filament, so I could have that keyguard printed by the Loveland Public Library for $4. And the library is then responsible for the materials, the purchasing of the printer, the maintenance of the printer, knowing how to use it. I don't have to worry about any of that. There are a ton of Facebook groups out there. You're not intended to read this. It's not intended for you to read this, just to know that there's a lot of Facebook groups out there. And in many of those groups, there are people who are dying to do something useful with their 3D printer. They've printed as many little doodads for their shelves as they can, and they're beginning to wonder, is there more to life for their 3D printers? Post to one of these groups. I guarantee you'll find somebody who's willing to do the printing for you. At most, they might want you to reimburse them for the cost of their materials and maybe postage. If you're in a parents group, you may be able to pool some resources within the parents group to purchase something. My guess is that in every parents group, there's at least one dad who's a closet techno guy who would love to be the one who's responsible for researching a printer, purchasing it, learning all about how to use it, and doing the printing for everyone in the group. Does 3D printing have a dark side? Yeah, this is probably the major one for me. Once you have a 3D printer and it's really cool, you start to see every problem as something that you need to solve with a 3D printer. And that may not necessarily be the case. I'm gonna go ahead and stop right now since we're just about out of time and open it up for questions. Please raise any questions you may have in the chat, and I'll attempt to answer them now. I'm also happy to answer any questions you may send to me to my email address. Remember that this software that I'm talking about here for creating keyguards is free to use. There are no strings attached to this. And there are full instructions on how to use it, how to get the necessary supporting software, and all of that's on the website, volksswitch.org. which is at the bottom of every one of these pages in the presentation. So the first question we have is from Valerie saying, I have a high school class, print out 3D keyguards for AAC apps on the iPad for me, but have yet to figure out a good way to attach the keyguards, I assume, to the iPads. Any suggestions? So hopefully, as in that part of the presentation where I showed you various mounting methods, you have some ideas now about at least the mounting methods that are supported by the Keyguard designer. And to be honest, my personal favorite is microsuction tape. You can get it really cheap from Amazon, and it sticks really well to any glass surface, and it even seems to stick well to screen protectors without leaving a residue behind when you pull it off. What CAD program am I using? Well, it's OpenSCAD, only because that's the environment that the Keyguard designer has to run inside of. I have used other programs for other purposes. Valerie says, the lamp words for life keyguards I have made don't have any remade holes. I'm not sure what a remade hole is. They are a design from Thingiverse or Yagi.
Typo.
So, oh, hey.
Pre-made holes.
Oh, pre-made.
No, I'll have to
Okay.
try the microsuction tape. I know our ed tech department, we have lending library iPads that people want to borrow, but they need key guards, and lamps one they often ask for key guards for. So I have a bunch of key guards, but the tech department doesn't want us sticking anything on the glass. But you think the microsuction tape will alleviate that problem?
Oh, it's magic. It
All
is
right,
magic.
I wrote it down. I'll have to look on Amazon and see about ordering some.
Yeah, and I have a link even on my webpage. I have a link to a nice big sheet that I purchased.
Oh, okay. Thank you.
It's inexpensive.
Yeah, they just didn't want me to stick Velcro or anything on it,
No, yeah. Well, that's old tech.
which I wasn't going to do.
Yeah. And it just assumes that you have enough underside surface for putting the tape on. With screen protectors, they can come right up to the edge of the screen. So sometimes you have a very thin key guard. Let's see. Sid says, do build kits come with all the tools to put it together? Pretty much, yeah. I mean, it's in many cases, it's just an Allen wrench to hold the pieces together. Some printers you put together by just putting two major chunks, the rest major chunks together. The two major chunks have already been assembled by the manufacturer. Okay, and again, if you have any questions afterward, and even once you take a look at any remaining slides in the slide deck, please feel free to contact me. I really do want to see you be successful. Oh, well, hey, let me just say one more thing here to get through these quickly. So we came up with this tool that's really critical to measuring for a key guard, simply because getting this inside measurement of the case is critical for the fit of the key guard. So, and it's hard to do that with a standard ruler. So it's called the Easy Measurement Tool, and it costs, actually, let's see, it costs nothing to print this, because if you send me an email saying that you want one of these easy measurement tools, and then I will send you one for free. All right. Sorry to keep you the extra time, and sorry for that crazy beginning.